Next one is coloring of a graph. Coloring of the graph, one of the main way is to color the vertices of graph G such that no two adjacent vertices have the same color. It is called as proper coloring. Means two adjacent vertices should not have a same color. That is the coloring of the graph. So how many minimum colors will required as per this condition, that is called as a chromatic number for that particular graph. You can see here the example. So this is the graph and the minimum number of 3 colors are required to color the graph such that two adjacent vertices is not having the same color. So in this case xg, it is denoted by xg, chromatic number is denoted by this xg is equal to 3. So this graph is called as a 3 chromatic. So what is exactly chromatic number? So the chromatic number of graph G is the minimum number of colors required for the proper coloring of the graph G. That is called as a chromatic number. Now there is some fixed values as per the different types of the graph. Chromatic number is means having after experimentation they get these chromatic numbers for these types of the graph. So we will see that table. So complete graph Kn, n is nothing but this is complete graph with n vertices. So this Kn is always required n number of color to properly coloring that particular graph. So two adjacent vertices will not be with the same color. So it requires n number of colors. Means suppose if you take a K5 graph, K5 graph means complete graph with 5 vertices. In that case we require 5 colors. In the same way K2 will require 2, K3 will require 3, likewise. Then star graph Cn means star graph, we'll see next slide is showing the actual graph. So Cn where n is greater than 1, so chromatic number for this will be the 2 for star graph. Then cycle graph means it forms a cycle. That for that graph chromatic number is a 2 for 2, chromatic number is 2 if n is even. In case of cycle graph means if it contains even number of vertices, in that case it will require 2 color. If it is contain an odd number of vertices, that is suppose 5, 3, likewise, so it will require a 3 color and chromatic number is 3 in that case. For a wheel graph Wn, n is greater than 2 means number of nodes should be, vertices should be greater than 2. In that case 3 chromatic number is 3 for wheel graph if number of vertices are in odd in number, and chromatic number is 4 for wheel graph if n is even. So whatever we seen in the table we can check. So one by one we will check. Complete graph Kn, this is the complete graph with the 6 vertices, you can see that. And for this complete graph with the 6 vertices we required 6 colors to satisfy or properly fill or color this graph. Okay, then we seen that star graph and number of vertices are greater than 1, so it required always 2 color. This is the star graph, 2 adjacent vertices are with is with the different colors or should not be with the same color. To satisfy this star graph is required 2 colors. So chromatic number is 2. Then cycle graph, this is the cyclic graph. So cyclic graph we required, we seen that if n even number of vertices in the graph, in that case we require 2 colors. If odd number of vertices, then we required 3 colors. So number of vertices in this case are odd, that's why we required 3 color, that is yellow, red and this yellow shade. Second example of the cyclic graph here number of vertices are even vertices, so we required only 2 colors. You can see that. Then next is a wheel graph. In case of wheel graph, n is greater than 2, and if number of vertices in the wheel graphs are odd, in that case we required 3 colors. So in this case number of vertices are 5 and it is odd, so wheel graph will require 3 colors. You can see that these 3 colors are used. And if in case of wheel number of vertices are even in number, so in this case it is 6, and so it required a 4 color if n is even. So you can see that 4 different colors we require to properly color this graph. So there are some observation. A graph which has only isolated vertex has kg is equal to 1, means chromatic number is 1. A graph with one or more edge without a self loop has minimum chromatic number is 2. A graph consisting of simply one circuit with n is greater than equal to 3 vertices has chromatic number as a 2 if n is even, and kg is equal to 3 if n is odd, means if kg is 2 means chromatic number is 2 if n is even, and chromatic number is 3 if n is odd. Every tree with 2 or more vertices has chromatic number as a 2. If d is the maximum degree of the vertices in a graph G, then chromatic number is lesser than is equal to d plus 1. Now we'll see some case studies or application of the graph theory. So Königsberg grid problem. This problem stated here. If you start from any 4 land, so in this case you can see these four lands are exist. This 1, 2, 3 and this side 4. So start from any 4 land area, walk over the 7 bridge. These are the bridges 1, 2, 3. These are the bridges 1, 2, 3, 4, 5, 6 and 7. These are the 7 bridges. Start from any 4 land area, walk over the 7 bridges exactly once. Vertices represent, so in this problem what they said that start from any 4 land area, walk over the 7 bridge exactly once. Is it possible or not? So we seen that the Eulerian path, in that case every edge should be visited exactly once. In the same thing is here, you have to travel from any one land and visit each and every bridge exactly once. So we can represent this problem in the form of graph. So these land areas will be represented by the, you can see that land areas is these 4 land areas represented by the vertices, and bridges are represented by the edges in this graph, and we can check whether Eulerian path is exist in this or not. So we know that what is the condition for Eulerian path, existence of Eulerian path. There should be 0 or 2 vertices with the odd degree. So if you see in this graph, vertices, this vertex with the odd degree, this vertex is odd degree, this is also with the odd degree, this is 3, 4, 5, all vertices with the odd degree. So condition is that 0 or 2 vertices should be with the odd degree, then only Eulerian path will be exist in that particular graph. So this condition is not satisfied, that's why it is not possible. Whatever statement or they said that start from any 4 land area and walk over the 7 bridges exactly once, it is not possible. That we can prove by the theorem of the Eulerian path. Okay, so vertices represent the land area and edges represent the bridges. In order to prove that the solution of this problem does not exist, I given a reason what is the why it is not exist. Then next problem or application which is used to for utility problem. So in this case you can see that there are three homes H1, H2, H3, and there are three utilities. These are the utilities and it is represented in the form of graph. These are the homes and these are the utilities. Utilities are, one is a water, second is a G means gas pipeline, and E is nothing but electricity. So is it possible to provide such a connection without any crossover? So what they said that there should not be any crossover between these three services. So is it possible or not? So you can see that so this problem we can check by the planar graph theorem. So here this graph can't be drawn on the plane without crossing the edge. Means planar graph, we know that planar graph is a graph which is drawn on the plane without any intersection of the edges, but it is not possible to draw on the plane without intersection because these two surfaces are intercross with each other. That's why it is not possible. So this problem we can't this connection without any crossover is not possible. One crossover is there. So this is all about the fourth unit, that is nothing but the graph theory. So we can thank you for everyone.